Hey there, mathematicians, and welcome to today's mini lesson. I'm so excited to continue working on multiplication and arrays with you digitally today. So we're going to continue talking about arrays. As you can see here, there's 3 different strategies we're going to learn together, and we're still kind of working in this array area. And we're going to be moving to partial products algorithm very soon, this week actually. And as we move to that, we're going to connect this algorithm array to our multiplication arrays that we've been working on together. So it's so important that we first have a really good understanding of this, and then we can move forward and learn how to be even more efficient. Today, I just want to review something we talked about on Friday, and that's the fact that mathematicians choose to decompose factors in a variety of ways. They can decompose in ways that will help them find accurate products. So in all of these arrays, we're really multiplying 2 factors together. And the first factor is 22, so we've got 10, 10, and 2, 22. And the second factor is 20, 10, and 1, which is 31. And if we look at all the arrays, we see 22 here and 31 here. We see 22 here and 31 here. So all of these arrays represent 22 times 31. But in each of these cases, the mathematician decided to decompose the numbers differently. And that is okay for you to do as a mathematician. As long as you've got all parts of each factor and you're multiplying all parts by all of the other parts of the factor, you can decompose these numbers in any way that you find fit. And that is going to lead us into our conversation today, which is all about organization of arrays. So one thing that your teachers and I have noticed is that over time, we've gotten kind of disorganized with our arrays, and it causes us to not be so accurate. So I want to show you this array. Mathematicians must be organized with arrays in order to be precise and accurate. So here is 28 times 17. So as I look at the array, I see 10, 11, 12, 13, 14, 15, 16, 17, right here. And 28, 10, 20, 21, 22, 23, 24, 25, 26, 27, 28. So my array is set up the correct way, but this mathematician, I don't know, I'll let you decide. Do you think they're organized or not? Go ahead and enter your thinking into PlayPosit. Do you think they're organized or not organized? So I'm thinking you probably wrote that they were really disorganized. And what happens when you become disorganized with arrays is that a lot of times your answer is not able to be accurate because you have numbers all over the place and you're not able to put those numbers together in order to find an accurate answer. And you'll notice as we have more ones here, it's really difficult to stay organized. So this mathematician could have composed the numbers maybe to like 10, 5, and 2, and 20, 5, and 3, but instead they listed all of those ones. So this is a really disorganized array, and they're likely going to have mistakes when they try to find the answer. Here's another one. I want you to think about, is it organized or not? So go ahead and type into PlayPosit. Do you think that this is an organized array? Yes or no? And explain why. So it definitely looks much more organized than the one we just looked at. So in the one we just looked at, numbers were all over the place. But in this one, the numbers are pretty close, together. They're lined up in a way that's really easy to see. But one thing I noticed as I was looking at this, so I see 10 times 10 is 100, 10 times 1 is 10, 1 times 10 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 is 10, and 1 times 10 is 10, but there should be 1, 2, 3, 4, 5, 6, 7 rows. There's of those 10, 10, 1, 1, 1, 1, 1. But there's 1, 2, 3, 4, 5, 6. So this mathematician didn't have enough rows that they were multiplying by 1. So now their answer is not going to be accurate because they didn't stay organized. They didn't keep the numbers in line with the numbers on the outside, so they lost track of how many times they were multiplying. So because this isn't right lined up with the 1, it looks like it's been multiplied enough, but it really hasn't. So let's look at this last example together. We see 28 times 17 again. It's the same problem. I want you to look at this one and decide, is it organized enough to find an accurate answer, and why or why not? All right, so this one is much more organized. We see all those numbers lined up in a really neat way. We also see that the numbers are lined up with the numbers on the outside of the array. So 10 times 10 is 100. It's right there lined up with those two 10s. Again, 10 times 10 is 100, lined right up with those 10s. As we look across at the ones, we're seeing that all the way across, they're lined up. But one thing I did notice is that 1 times 10 doesn't actually equal 100. It only equals 10. So they did make a little error here with multiplying by 1. But if I take those zeros off and change those to 10s, they are now accurate as well. So now they can quickly look at all of those 10s, add them together, all those hundreds and all those ones, and they're going to much easier be able to decide what the product of 28 and 17 is. So as mathematicians, we really need to think about our arrays and how organized they are. Because if we're not organized with our lining up of the numbers in the array, we're going to have a lot of problems finding an accurate answer. So I really want you to focus on that today as you work on arrays and in the future as we do it in class together. We're now going to head into rotation time. And for rotations, I want you to make sure that you are using all of these behaviors that support mathematicians. Remember to work the whole time. Of course, if you need a break, please take a break, but get right back to work so that you can focus in and finish. Respect your colleagues, so if you've got family or friends around today, be respectful to them as you work, put on headphones, and keep your voice quiet so that they can focus as well. Manage your time wisely. Don't take too long to do things. Just do your best and move on, and always bring your best. So work hard to be your best in everything that you do today in math. We're so excited to see all the things that you do. Please click next to move to the next part of your day. Have an awesome math workshop, everyone.